Hi, everyone. This is lesson 4.2. So if you're watching this from my college algebra class, you should have the take-home notes to go with this. So when we return to class, we're going to pick up in the section after this and start learning about factoring. So in order to do that, we do need to have this foundation of knowing how to multiply polynomials. So a lot of this you should already know because you would have just reviewed the properties of exponents in a different section. I believe that's R.7. You should also already know about the distributive property. We'll also cover FOIL and then multiplying longer polynomials. Near the end of this section, we'll see some special products. So for example, what it looks like to do a plus b in parentheses squared, squaring a binomial. And then there's another formula called the difference of squares. So that's kind of the overview of what we're going to see here. What we're looking at first is multiplying monomials and then distributing a monomial into a binomial. So mono means one, there's one single term. We've seen problems like this before when we were covering just properties of exponents. So in this first example, 5x to the third y to the fourth times negative 3x squared y squared. You multiply the coefficient numbers, so 5 times negative 3, there's your negative 15. And then for each set of variables, for the variables that are the same, you'll use the product rule to add the exponents. So for the x's, those exponents are 3 and 2, so we add those to get 5, so x to the 5 or x to the 5th. And then for the y's, y to the 4th times y squared, we would add 4 plus 2 and get 6. So we multiply the coefficients, add the exponents. That's what it's like to multiply monomials. We're going to build on that when we start distributing and multiplying longer polynomials. We still need to keep that same idea in mind. We're multiplying coefficients, adding exponents. It's just that now we're going to be distributing. Okay, so the next example, multiplying monomials and binomials. So essentially distributing. And here's our example, 4x parentheses 5x minus 2. So this is where you'll often see a teacher draw arrows. Maybe you're used to doing that too. That's just kind of showing that we're distributing to each term inside the parentheses. So 4x times 5x gives us the first term, 20x squared. Notice how we're multiplying the coefficients. 4 times 5 is 20, and we're adding the exponents. 1 plus 1 is 2. And there's a 1 on those x's, even though you can't see it, that's a 1 exponent for each variable. And then, of course, the next term, 4x times 2, is just 8x. And we're done. We don't combine them because these are not like terms. The variables do not have the same exponent, so we can't combine them. Our final answer has two terms, 20x squared minus 8x. So that's using the distributive property or distributive law. And then for some longer polynomials, that's the next example you see here. We have a trinomial times a binomial. There's no special formula to go with this necessarily. The sentence that we read says, to find the product of two polynomials p and q, multiply each term of p by every term of q, then collect like terms. We're distributing. So I'm going to just demonstrate what's going on here, drawing some arrows, maybe using some different colors. So what I'm going to start by doing is distributing the x squared. So x squared times x gives us x to the third plus x squared times 3 gives us the plus 3x squared. So those are the first two terms that you see written. And then we'll move to the second term in the polynomial. The second term is that minus 4x. So then we start distributing that. So negative 4x times x is minus or negative 4x squared. Negative 4x times 3 is minus 12x. And finally, there's a third term that we get to distribute, which is just a 5. So we'll multiply everything in the second polynomial by 5. So 5 times x, 5x, 5 times 3, 15. So we just multiplied a trinomial times a binomial. So 3 terms times 2 terms. We have 6 terms altogether. And now what we need to do is combine like terms. So I have all these colors going just to show you where the terms came from, but I'm going to erase those and then sort of use some new colors to show where the like terms are. Okay, so descending order is a good idea. Having the highest power go first, x to the third. There's your highest exponent. There's no other terms that have that exponent, so there's nothing that we can combine with that. So we're just done with that term. It's just x to the third. We just bring it down. The next terms that we can combine are the ones with x squared. So the ones with the degree of 2 3x squared minus 4x squared would be minus 1x squared. So you see, we just wrote minus x squared, but you can write that 1 if you want to. You could write minus 1x squared. That's still correct. And then the next terms that can be combined both have x. So minus 12x plus 5x. Make sure that 12 does have that minus sign in front of it. Treat it like a negative 12. So negative 12 plus 5 would be negative 7. So there's that minus 7x. And finally, you have a constant term at the end. That's just the regular number plus 15. So notice how we ended up giving our answer in descending order. So I'll type that out so you can see the spelling for that. Descending order. That means highest exponent to lowest. Not always required, but a good idea. Kind of like alphabetical order, only we're talking about math terms here. So it's a good idea to just always do it that way so that when you are asked to put the answer in descending order, you're just already doing it automatically. Okay, so I think we get to move on and do some examples on our own here. So we're on to the next page. So we kind of have one of each that are similar to what you just saw. Example 1, we're multiplying two monomials. So I'm going to type that word out, monomials, meaning single terms. So here's where we're multiplying the coefficient numbers. So the original problem is negative 7a squared bc to the third times 3abc to the fifth. So we'll multiply the coefficients. Negative 7 times 3, there's negative 21. Then we'll multiply the powers of a squared times a to the 1. Having trouble writing that small, but our exponents are 2 and 1. So we're going to be adding those exponents together. 2 plus 1 will become 3 in our final answer. We're also adding the exponents on the b's. 1 plus 1 is going to be 2, or b squared for the final answer. And then we'll add the exponents on the c's. 3 plus 5 is going to be 8. So let's write out the full final answer here. Negative 21, a to the third, b squared, c to the eighth. So we multiplied the coefficients, and then we added the exponents on the variables that were alike. Okay, so for those of you watching this in my class, I will hand you an answer key, or maybe it's attached to your notes. I'll have all the answers for the your turn problems if you want to try them on your own. But for now, I'm just going to be showing the official examples on the left side. But you can always try the problems on the right side. They're going to be similar. Okay, here's our next one, example 2. This is where we are distributing. So we're multiplying a monomial times a binomial. So we're distributing now. All right. So 2a squared times 4a to the third. Now you can see there's some detail that's already typed out here. You might not choose to show quite this much work if you're just doing it on your own. What you might choose to do is just kind of go straight to the final answer. Maybe you're doing the multiplying in your head, which is fine. 2a squared times 4a to the third. We're doing 2 times 4, which is 8. You can see that as part of the final answer. And then a squared times a to the third. Add the exponents, 2 plus 3 is 5. So that's where that first term comes from in the answer, 8a to the fifth. Next, we'll distribute 2a squared times 5a to the fourth, bringing along that minus sign. Okay, so I guess if we're filling in the blank here, 2a squared is what we're looking for. So 2a squared times 5a to the fourth. Again, I would kind of just skip that middle step and just go straight to the final answer. But if you want to write more detail, that's great. Then we multiply 2a squared times 5a to the fourth. 2 times 5 is 10. And then a squared times a to the fourth. We add the exponents, 2 plus 4, and get 6. So that's going to be 10a to the 6. Okay, so to give the full answer, oops. All right, here's our full final answer. So 8a to the fifth minus 10a to the 6th. There's our final answer. And once again, we have different degrees, different exponents on our variables. So we do not combine those terms because they are not like terms. All right, I guess we get to move to a longer one next. So this is example 4. We do a trinomial times another trinomial. This one's going to be long. So what I would recommend for a long problem like this, rather than just having one long horizontal line of all of your terms in a row, that can get a little overwhelming to try to keep organized. What I'm going to do is use columns. So I guess, yeah, columns or rows, I guess both. So what you'll see is as we're distributing, I'll distribute the first term those first terms will all go in a row together. Then I'm going to distribute my second term, and those terms will go in a new row. And in terms of columns, what I mean by that is I'm going to line up the like terms. So they're already in columns together. They're already organized and ready to be combined. So you don't have to be searching for them later. I think this will make sense once you see it. So let's get going. So here's our problem. So our first trinomial is 3x to the third plus 2x minus 2 times negative 2x squared plus 4x plus 5. So notice we have an x to the third in the first polynomial, and then we have an x squared in the second one. So just notice that. But even so, we'll start by distributing. So 3x to the third times negative 2x squared, that's going to be negative 6x to the fifth. So 3 times negative 2 is negative 6, and then we add the exponents. 3 plus 2 is 5. Next, 3x to the third times 4x, that's going to be 12x to the fourth. So again, I'm multiplying the coefficients, adding the exponents. And then my last term for now, 3x to the third plus times positive 5 will be positive 15x to the third. So there's my first row. Those are my first 3 terms. I'm now done distributing that first term. So I'm going to cross it out just to keep track of what I've done so far. And then we can start kind of doing the same process again with the second term. This time we're going to be distributing that to x. Okay. So as I start writing my terms, I'm going to try to line them up with any like terms that already exist from the previous row. So that starts with this first term here, 2x times negative 2x squared. That's negative 4x to the third. So I'm going to write that directly underneath the 15x to the third, because since they're both x to the thirds, I know they're going to be like terms. So later when the problem is done, we'll be able to combine those. Okay, next, 2x times 4x, that's going to be positive 8x squared. There's no other x squareds here, so there's nothing to combine with it. I just kind of put it off to the side. And then 2x times 5, that's 10x. Okay, I've almost taken up my whole screen here. All right. And then finally, let's see, we get to distribute that minus 2. So even doing it this way, I'm still a little short on space here, but that's okay. All right, now we're going to distribute the minus 2. We'll do that in blue here. Minus 2 or negative 2 times negative 2x squared would be positive 4x squared. So I'll write plus 4x squared right under the 8x squared. Because again, same reason, they're like terms. Next, negative 2 times 4x would be negative 8x or minus 8x. I'm writing it right with the 10x. And if I had more space on my screen, I would shift even more to the right for the very last term. Negative 2 times 5 is negative 10. I'm just going to squeeze it in the bottom corner there, minus 10. Okay, so the idea here is I was sort of lining up the like terms so that now when it comes time to writing the final answer, everything's kind of already ready to go. All right, here we go. So our final answer, negative 6x to the fifth plus 12x to the fourth. So nothing to do with those, just copying them down. And then now we get to start combining like terms. So positive 15 minus 4 would be positive 11 x to the third. So we combine those together. Next, we're going to combine the x squareds. 8 plus 4 is 12. So plus 12 x squared. Notice when we combine, we're not changing the exponents now. We're just combining the coefficients and keeping the exponent the same. Positive 10x minus 8x would be positive 2x. Okay, I'm just making a little space here. So plus 2x. And then the minus 10 is just there, minus 10. Okay, so it's still a nice long answer. Okay, so our final answer is negative 6x to the fifth plus 12x to the fourth plus 11x to the third plus 12x squared plus 2x minus 10. Okay, so the main idea there is you're distributing. As you're distributing, you're multiplying coefficients, adding exponents, and then at the end, combine like terms. If you liked lining them up like I did, great. If that wasn't for you, that's okay. As long as you're able to identify the like terms and combine them at the end, then it's all good. All right, Very good. So we have the main idea now for multiplying polynomials. We are going to focus on a specific type coming up next. You may have heard this before, using the FOIL method. FOIL is, those 4 letters stand for something. So FOIL stands for first, outside, inside, last. So this is specific to when you're multiplying 2 binomials. Bi means 2. So 2 expressions with 2 terms each is when you can use this method. But really, we kind of just used a version of this in our previous problem, a trinomial times a trinomial. It's just that we're out of letters. First, middle, outside, middle. I mean, there's not a nice short way to abbreviate what we just did, but we took each term and distributed it throughout the second polynomial. So we're really still doing the same thing here. It's just that if you want to use the FOIL letters to help you keep track of what you're doing, you're welcome to do that. Just know that it's still the same distributing process that you've already been doing. Okay, let's see. So you can see an example here. X plus 6 times x minus 3. So here's your first terms, x times x squared. There's your outside terms. X times minus 3 is minus 3x. I'm writing an O for outside. Then distribute the 6 times x, 6x. There's your I for inside. And then 6 times negative 3, negative 18. So FOIL, first, outside, inside, last. Oftentimes with this method, you'll be able to combine the middle terms. They will often be like terms, not always. But in this case, they are. So in this example, we combined negative 3x plus 6x and got positive 3x. Okay, so we have a similar example down below. We're going to multiply 2x plus 1 times negative 4x plus 5. Okay, so we start by distributing the 2x. Here's our first terms. Negative 2x times negative 4x is negative 8x squared. There's our first term. First terms multiplied together. Next, 2x times 5 would be 10x. So you have a fill in the blank here, plus 10x. That's your outside terms. Okay, and then our inside terms, 1 times negative 4x would be negative 4x. That's your inside terms. And then finally, 1 times 5 would be 5. Oops. That's our last terms. So negative 8x squared plus 10x minus 4x plus 5. And we get to combine the middle terms. So the 10x minus 4x combines to positive 6x. So our final answer is negative 8x squared plus 6x plus 5. Okay, so that's a really common type of answer here where you have a binomial times a binomial. 2 terms times 2 terms becomes 4 terms, but a lot of times the very final answer is a trinomial, tri meaning 3. So a lot of times we end up with 3 terms by the time we're done because we're able to combine the 2 terms in the middle. All right, and the next thing we're going to look at is some special products, so some special formulas you can use to multiply. What I want to say about these formulas coming up is you don't necessarily need to even use these or memorize these. As long as you're comfortable with FOIL, you can just rely on that every time and it will work just fine. So I just want to keep that in mind as you're looking at these formulas. Formulas are great as patterns that you notice. They eventually can become very useful, but the very first time you see them, it might be a little overwhelming to try to memorize all of them. Remember, the whole idea of a formula is it's a pattern somebody noticed after doing problems over and over, and that can be the way you approach it as well. So hopefully you'll start to notice these patterns yourselves. Otherwise, you can just FOIL. So we first have squares of binomials. So when you square something, that means you multiply it by itself, multiply one thing times itself. So in our example here, x minus 4 squared. Notice, first of all, you're not just squaring the x and squaring the 4. No, what you're going to do is multiply x minus 4 times itself. Okay, and if you were to rewrite that and actually FOIL, here, I'll bring that to the right side. I'm ignoring the formulas temporarily, but I want to show you the connection here. So when we FOIL, x times x squared. Then our outside terms, x times minus 4, that's minus 4x. Inside terms, it's another minus 4x. And then our last terms, negative times negative is positive 16. So notice that there's two of the minus 4x's, right? The outside and inside terms are the same. There's two of them. That's why we have this 2 in the formula. So when you're squaring a binomial, your first term is a squared, so square the first term. Your last term is b squared, square the last term, 4 times 4 is 16. And then in the middle, 2ab comes from multiplying the outside and inside terms and the fact that they're both the same, so there's two of them. That's really where the 2 comes in. So you can see an example of plugging into the formula here in the middle of the page. If that makes sense to you, great. If you'd rather just write these things twice in FOIL, then go ahead and just do that. It works just as well. Okay, so let's see example 2. This one has a fraction. Okay, so 1/4 x minus 2 is being squared. One way to do this is to use the formula. So I will show you in a little more detail right now how the formula can be applied. So I'm going to write the formula right below. So it goes like this, a minus b, Here, I'm going to use the blank space off to the right. Feel free to use a different space if you want to save the your turn problem, but I'm just going to put this off to the right so I have more space. Okay, so I'm writing it twice right now. 1/4 x minus 2. 1/4 x minus 2. Okay, we're going to FOIL right now, and then we'll come back and see the formula, and we'll see it both ways, okay? So let's see. So now I'm pausing here and trying to decide which way to do first. I think I said it both ways. Sorry about that. I'm so used to foiling. That's just what I'm used to. So let me finish what I started here, and I promise I will show you the formula too. All right, so with FOIL, here's what it looks like. 1/4 x times 1/4 x, that's 1/16 x squared. Remember, with multiplying fractions, you just multiply across. 1 times 1 is 1 for the numerator, 4 times 4 is 16 for the denominator. Okay, now for the outside terms, 1/4 times -2, if you can just put it over 1, 1 times -2 is -2, 4 times 1 is 4. I know that can be reduced, but I'm just going to leave it for now. So minus 2/4 x. And then the inside terms, -2 times 1/4 x again is, again, minus 2/4 x. We're going to be able to combine those together in just a minute. -2/4 minus 2/4 is -4/4, which is -1x, okay? So that's where that -1x comes from, as you're seeing already written for the answer. And then your last terms, -2 times -2, +4. So that's FOIL. First, outside, inside, last. Combine the middle terms together. -2/4 plus -2/4 is -4/4, which reduces to -1. So -4/4 reduces to -1x. Okay, so that's where that final answer comes from. 1/16 x squared minus 1x plus 4. Okay, so what you just saw was the FOIL method. Pause here if you need to. I'm about to erase and then do this problem again using the actual formula for squaring a binomial. Okay, so same problem again using the formula. So a minus b squared equals, okay, it's going to be hard for me to type this because I need to write some exponents. So I'll take it from here. All right. So a minus b squared equals a squared minus 2ab plus b squared. A is the first term, so a is 1/4 x. So there's your a squared right here. 1/4 x is being squared. That turns into 1/16 x squared. So there's your first term. And then when people have trouble with this formula, it's usually in the middle for some reason. So the minus 2ab, here's what it looks like. Minus 2 times 1/4 x times b, which in this case is just that last term, which happens to also be 2. And don't worry about the negative sign because that's already built into the formula. There's already a minus sign there. So just write 2 there. And then, of course, plus 2 squared. So all of this is already typed on the left side, but I just wanted to point out where it comes from. It's coming from that a minus b squared formula. So squaring a binomial. And then what's left to do is simplify each term. The 1/4 x squared, 1/4 x times 1/4 x becomes 1/16 x squared. And then multiplying all these numbers together, 2/1 times 1/4 x times 2/1, it becomes minus 4/4 x. If you multiply all the numerators, 2 times 1 times 2 is 4. 1 times 4 times 1 is also 4. 4/4 reduces to just 1. So really that middle term is just minus 1x. And then 2 squared would be 4 for the last term. All right, so I'm going to attempt to rewrite this over here. 1/16. Sorry, my writing isn't super straight right now. 1/16 x squared minus 1x, or just write minus x, and then plus 4. Okay, so I know the fractions complicated that a little bit there. I mean, maybe what I just demonstrated is the formula doesn't really make it any shorter or easier, in my opinion. I think still writing it twice and using FOIL is just as effective, if not maybe easier, until you start to notice the pattern yourself. You might find yourself using the formula after a while, just getting used to the fact that you have 2 of the same terms in the middle. But otherwise, writing it twice and distributing works just great. Okay, that's a tricky one for sure. The last special product we have, I think, is much more manageable, a little more actually useful. So this formula is called the product of a sum and difference. Sometimes it's also known as the difference of squares. So it goes like this: a plus b, a minus b equals a squared minus b squared. So here's our example: x plus 3 times x minus 3. If you follow the formula, all you have to do is the first term squared, so x squared, minus the second term squared, or b squared, in this case, minus 3 squared. So it just turns into x squared minus 9, nice and short. As I wrote off to the side here, you can still use FOIL. So, or you can still use FOIL, right? So you can still distribute, right? X times x, there's x squared. X times minus 3 is minus 3x. Positive 3 times x is plus 3x, and then 3 times negative 3 is negative 9. So you can still use that process. If you didn't happen to notice that it was in this pattern, a plus b, a minus b, x plus 3, x minus 3, you can still use FOIL. It's just that those middle terms would cancel, right? So minus 3x plus 3x cancels out, and you're left with just x squared minus 9. So once again, here's a formula, take it or leave it. Feel free to use FOIL on your own, distributing on your own, until you really are more comfortable using the formula itself. Okay, very good. We have, I think, one example to look at here. This one's a little more complicated because it has x's and y's in it. So I'm trying to show you both ways on the left side here. So 2xy plus 4x, 2xy minus 4x. So you have that a plus b, a minus b formula, or pattern, I guess. A plus b, a minus b. Okay, and so we know that that's equal to a squared minus b squared. So that's what's being shown here: 2xy squared minus 4x squared. So square the first, square the last, minus sign in between. So all we need to do is actually simplify. So squaring 2xy, square each individual piece there. So 2 times 2 is 4, x times x is x squared, y times y is y squared. Minus, and then 4x squared, 4x times 4x would become 16x squared. There we go. So there's our answer: 4x squared y squared minus 16x squared. Or, as you can see down below, you can use the FOIL method. So feel free to just distribute 2xy times 2xy. You still get 4x squared y squared. 2xy times minus 4x, we get minus 8x squared y. That's that outside term. Then the inside terms, 4x times 2xy is plus 8x squared y. And then our last terms, we get minus 16x squared. So those middle terms, when we combine them, they are like terms, but they actually just add up to 0. So that's why they're gone from the answer, and we still get the same final answer that we would have if we use the formula. Okay, good. So those are some special formulas for multiplying polynomials. And that's all we got for examples. What we have after this are some practice exercises. So I just want to give you a little preview. The ones at the top of the page, numbered 1 and number 7. Yes, the numbers, we're skipping some, so that's why the numbers are a little strange. These are multiplying monomials, so you can go back to that section at the beginning of the notes to remember how to do those. And it kind of just builds from here, multiplying monomials and binomials. This is where you're distributing, right, using the distributive property. Multiplying longer polynomials. So this might be a good one where you use columns to line up your terms. And again, if you're watching this in my college algebra class, we might do this one in class or something like it. We'll practice doing that longer multiplication of polynomials, lining up the like terms. And then we get to some FOIL problems. First, outside, inside, last. And finally, we have our special products. So you see number 17 and 18, we're squaring binomials, x minus 6 squared, 2x plus 3y squared. So you can choose to use the formulas if you want to, or what might work best is if you just write the expression twice and then FOIL. So just a reminder, x minus 6 squared is not x squared minus 36. No. You can't just square each piece individually. That's not what's going on here. So instead, write it twice, x minus 6, x minus 6. You get x squared minus 6x minus another 6x plus 36. So the final answer is x squared minus 12x plus 36. Okay, so it's a commonly, how do I want to word this? There's a lot of mistakes that people make with squaring a binomial. So just be extra careful there, and you can expect one of those on the test for sure. All right, and even if you're watching this from another class, just if your teacher has taught you this, they'll put one of those on the test probably. So, all right, and then the last two, 20 and 21, this is the a plus b, a minus b formula. So a plus 10, a minus 10, you can FOIL, or you can use the formula a squared minus b squared, done. So a squared minus 10 squared would become a squared minus 100. Okay, so I know some of the challenge is just knowing when to use which formula. And if you ever just panic or forget, remember FOIL. It'll work every time. So just distribute using FOIL and guaranteed you'll get the right answer, regardless of whether you remember the correct special formula or not. Okay, we've come to the end. That was section 4.2. And thanks for watching, and let me know if you have any questions. Thanks.